Let us wait for 2 more minutes while others are joining. Mohammed Sharif, you were not there yesterday. What happened?
Sir, I said I went outside.
Sorry.
Sir, I was out yesterday.
Yeah, yesterday there was a class. You missed that class.
Yes, sir, I watched that lecture.
Okay. Have you understood it?
Yes, sir.
Okay. Shahid, you also missed yesterday's class. So, did you see the lecture or understood?
No, sir, they didn't say send me the replay.
Okay, so you should have asked for it. Anyways,
They have asked.
okay, you have asked. Okay. So in today's class, we will be doing some new properties of inverse trigonometric function. And yes, there was a test also conducted after the class yesterday, and I saw the performance of many of you. So Madiha has been fairly well. Madiha has not joined till now. Austin, your marks was not good. What happened?
Sorry, sir.
The test which was conducted after the class.
Yes,
In
actually,
that,
I did not do that. I didn't know there was test, so it's randomly there was some options and sent.
okay, you didn't revise.
No, I just randomly chose some options. I didn't know there was a test.
Okay. So if you're not understanding anything in the class, you can definitely ask me. And there is no need to be ashamed of anything. And I will re-explain if it is needed. So, and others marks was also, let's see, I have got the result. So did 3 correct out of 6. Faza, your was also not good. You didn't, yours was, you didn't do any question correctly. What was the reason? Okay, you hadn't revised before. Humamuddin did fairly well, though it was the first class of Humamuddin, but it is okay. 2 questions were correct, but it still needs improvement. So I think almost everyone has joined, only Madiha has not joined. So the properties which we will be doing first is we did few properties yesterday, and today we are doing the first set of properties is that if it is given sine inverse of 1 by x, then it will be equal to cosec inverse of x. And the condition here is x is mod of x is greater than equal to 1, or the same condition, you can say that, or you can say that x is belonging to minus infinity comma minus 1 union 1 comma infinity. So how does this happen? Like if you take sine inverse 1 by x as an angle theta, because 1 by x is a value and theta is an angle. Sine inverse is the inverse trigonometric function. And since x mod x is greater than equal to 1, so 1 by mod x will be less than equal to 1 and greater than 0. So we can say that 1 by x belongs to minus 1 comma 1 except 0. 0 we can't take because x is in the denominator. So we can take its angle. So if we apply sine, so sine inverse 1 by x is equal to theta. So this would mean that this is the condition here. So this would mean that sine will be applied on the right hand side also. So it will be sine theta. Madhya, you joined little late. What is the reason? Am I audible to you?
Yes, sir.
Okay. So as we studied yesterday, sine and sine inverse will cancel. And it is 1 by x is equal to sine theta, which would mean if you take the reciprocal, that is x, so it will be 1 by sine theta, which will be cosec theta, as we know. Now, if we take cosec inverse both the side, so this will be cosec inverse cosec theta, and this will be theta. But why it will be theta? Because the principal value range is same for cosec and sine. Okay, so this is how we can write it. So this is theta. Now from here, this is the second part, second equation, and this is the first equation. Theta is sine inverse 1 by x as well as cosec inverse x. So therefore, sine inverse 1 by x is equal to cosec inverse x. So this is the first property which we prove like this. This is one of the first property which we are going to do today. So you can write it down, and if any step is not clear, you can ask me and I will explain.
Sir, here in sine inverse 1 by x, the mod x, it's a condition that it should be equal to 1 or greater than 1.
Yeah, because mod x is greater than equal to 1, then 1 by mod x will be less than equal to 1. And sine inverse can take input, which is between 1 and minus 1. So that is why we want this less than 1. Same thing, which is you are writing in terms of mod. If you write it like this, both are same thing. If you understand like this, then it is in short, and this is a log form of this. Similarly, this is the short form, and this is the long form of the same.
So it will not be equal to 0.
No, not equal to 0, because x cannot become infinite, because infinity is never included.
Yes.
So we can't take it at 0. So have you written it?
Yes, sir.
Yes, sir.
Now, as we discussed yesterday, one important thing is here, which is not uh, making any difference here, but in some case it may make difference. So if you see over here that when you apply this property that sine of sine inverse 1 by x, so this becomes 1 by x. That is sine and sine inverse get cancelled. They are inverse function of each other. Whereas when you apply cosec inverse x, here you apply cosec inverse x and you apply cosec inverse here also. So cosec inverse and cos also get cancelled. But as we discussed yesterday, right, that like if you are taking a value here and that value is in between 1 and -1, as we see here, then sine and sine inverse will cancel. But if you take angle here, so what is the difference between these two? That this is a value, and this is inverse function, and then there is trigonometric function. Here there is an angle, and this is a trigonometric function, and then there is an inverse function. So it is not similar type of activity going on. So if theta is any angle, then cosec theta gives you a value, and then cosec inverse of that value gives you the angle theta. But what we keep in mind that cosec inverse and cosec will cancel if theta is in the principal value range, as we discussed in the yesterday class. Now, is theta in the principal value range? So first thing which we have to specify here when we are writing it, so you can say then when we have taken sine inverse 1 by x is equal to theta, there only, since sine inverse gives the value angle between minus pi by 2 to pi by 2. So this will be between minus pi by 2 to pi by 2 except 0. Because obviously we are not including 0 here. 1 by mod x is not equal to 0. So that case is not included here. Now, if you see here, this theta is the same theta. That is theta belonging to minus pi by 2 to pi by 2 except 0. So here we can say that that is also the principal value range of cosec inverse. So we can cancel them and directly write theta. So that is fine. Similarly, if you take, let us take one question based on this first. First, write this angle concept. Extra thing which I have written right now, this and there one thing. This you should write also.
Sir, what is this PV full form?
PV is the principal value range. Who is asking?
Okay, sir. Me, sir, Chavez.
Oh, Shaved, yesterday class you missed, no?
Yes, sir. Wi-Fi was not there.
Okay, so yesterday we did that, no? Principal value. Principal value we did in the first class also.
Yes, yes, sir.
This is principal value. So this we have seen. Similarly, if you do for cos inverse 1 by x equal to sec inverse x, or here we can also write cos inverse x equal to sec inverse 1 by x. Only thing which we have to keep in mind is that means if here it is 1 by x, here it will be x. If here it is x, it is 1 by x. That is reciprocal. Only thing we have to keep in mind here that if we are applying this, then mod x is greater than equal to 1. That means x belongs to minus infinity comma minus 1 union 1 comma infinity. And if we are applying this, that is cos inverse has an input x, that means that value should be less than equal to 1. That is x belonging to minus 1 comma 1, except 0, of course, because we want 1 by x to be defined also. So we won't take 0. So mod x is less than equal to 1, except 0 we can write. So both of them is okay. So we can proceed taking any one of them. Only thing is that the input of sec inverse and cos inverse are reciprocal of each other. Now here, if we see, if you want to prove it, we'll start like that. That suppose cos inverse 1 by x. I'm taking the first part only, this one. So yeah, in the previous case also we have taken this variety. You can take second variety also, but if we are taking one variety, we should stick with that. Stick with that. So cos inverse 1 by x is equal to theta. So here you have to write that theta belongs to 0 comma pi, because that is the principal value range of cos inverse, except pi by 2. So because we are not taking x as 1 by x as 0, because 1 by x is not equal to 0 and cos pi by 2 is 0. Then we will say that cos inverse of 1 by x is equal to cos theta, which means that this is 1 by x is equal to cos theta. This was the condition with that one. So cos and cos inverse will cancel and 1 by x would be there. Here, since 1 by x is a value which is mod x is greater than equal to 1, means 1 by x is less than equal to 1, except 0.
Sir,
Yeah,
here we are not taking 0 because it will be undefined if you're taking it.
yeah. So we can cancel cos and cos inverse because 1 by mod x is less than equal to 1 except 0. Or we can say that 1 by x is between 1 and minus 1 except 0. So this is we have. Now we take the reciprocal. So this will be x. This will be 1 by cos theta. And 1 by cos theta is written as sec theta. So when we write it as x is equal to sec theta, I will give you the time to write the portion which is above. So x is equal to sec theta. Now the important part is we take sec inverse both the sides. Now sec inverse sec theta. Now this sec inverse and sec will cancel only if theta is in the principal value range. And we can see that we have taken theta, this one, which is actually the principal value range of sec. So we can say that sec inverse x is equal to theta. Sec inverse and sec will cancel and this is equal to theta. So cos inverse 1 by x was theta and sec inverse x is also theta. So we can equate this first and second equation and say, therefore, cos inverse 1 by x is equal to sec inverse x. So from here you can write. First write till here, then I will scroll down. Faza is asking, sir, will proving questions for this come for test? Proving does not come for test, but these proving is very important because these concepts actually use in questions. And the derivation which I am doing here, you will understand this and its importance when we are going to do the third one, that is tan inverse. Because in tan inverse there is some change, and why that changes, that you have to understand. So in sine inverse and cos inverse, it did not make much difference, but in tan inverse it will make difference. So these concepts are very important, and question just value based questions does not come in competitive exam like JEE. So if you are parallelly preparing for CBSE and JEE also, as well as CUET maybe, so board exam is important, and even board exam also does not just take the value, just take the formula based question. Some difficult questions are there also, around 25% to 30%, which are concept driven. So you have to understand the derivation behind it. The whole story of this chapter is principal value. Everywhere you will see the principal value will try to intervene and make changes when required. So that's why it is very important for you to understand these all aspects, these all formula for principal value. If you have written till here, you can just tell me, I will scroll down.
Sir,
Yes,
here how we can tell cos inverse 1 by x is equal to theta, first equation. Where did we get this?
that we have taken. Let
Oh,
that
okay.
cos inverse 1 by x, for example, x is a value which is suppose 2. Suppose we have cos inverse 1 by 2. So we know that cos inverse 1 by 2 is equal to pi by 3. So this we call as theta. Okay. Because cos of pi by 3, cos 60 degree is 1 by 2. I'm scrolling it down. I hope you have written it. So we'll do few questions right now. Then you'll see the tan inverse. What happens there? So if I give you, I hope you have written this part. So if I give you questions like what is uh, cos, no, let us take sec inverse, and you can use this property. Sec inverse minus 2 by root 3. What is cosec inverse uh, minus root 2? What is sec inverse 2? So try these three questions first. So one thing which you will do is first apply the property. So sec inverse minus 2 by root 3, if you see. So generally we don't remember the trigonometric values of sec and cosec. We remember sine and cos. So we can write it as cos inverse of minus root 3 by 2. So we'll take the reciprocal. 1 by x become x. Or if it is x, it will become 1 by x. So we'll write minus root 3 by 2. Now, at what angle cos is minus root 3 by 2? And you have to remember principal value. So principal value of cos is 0 to pi. So the value must be between 0 to pi. So the first quadrant is 0 to pi by 2, where cos is positive, and this is a negative value. Second quadrant is pi by 2 to pi. So you have to search the value between pi by 2 to pi, where it is negative. So if I ask you cos is minus 30 degree, no, Sharif, how can it be minus 30 degree? No, it is not the principal value. Principal value is 0 to pi of cos. Principal value of cos is 0 to pi. So you can't get an angle outside this. And even at minus 30 degree, cos is plus root 3 by 2. It is not minus root 3 by 2. Cos absorbs the minus sign.
120 degree.
Sorry,
120 degree.
120 degree. So 120 degree you are saying, but 120 degree cos will be like if you take cos of 120 degree, what will happen?
Sir, 150 degree.
It will be 150 degree, correct? Because if you take cos of 150 degree, it would be cos of 180 degree minus 30 degree, which is minus cos 30 degree, is minus root 3 by 2. So it is 150 degree. The angle is 150 degree. So 150 degree is in radians, it is 5 pi by 6. Similarly, second question, try second question. So cosec inverse minus root 2 means sine inverse minus 1 by root. And principal value of sine, we all know it is between minus pi by 2 to pi
135
by 2.
degree.
No, why it will be 135 degree? It is sine, it is not cos. Sine has principal value between minus pi by 2 to pi by 2. So basic thing we have to remember. That is why I'm always saying this chapter is about principal value. So what you are doing in cos, you can't do same thing in sine because 135 degree is in the second quadrant. Sine will be positive there. It will not be minus 1 by root 2. If cos is negative, it does not mean sine will also be negative. So sine principal value is minus pi by 2 to pi by 2. So 0 to pi by 2, it is positive. Minus pi by 2 to 0, it is negative. So here what will be the angle? Sine of minus
Yes, whatever.
45 degree, because this will become minus sine 45 degree. In sine, minus sign comes outside, but cos it does not happen. So everything is related. There is some reason behind giving the principal value like this. So this is minus 1 by root 2. And this minus 45 degree means minus pi by 4. So this is minus pi by 4. Last is sec inverse 2. This means cos inverse 1 by 2. So here I have not given a negative input.
— 60 degrees.
60 degree, that is pi by 3. Cos 60 degree is half. So this is what we have, the types of application. Now, if we see third type, that is tan inverse of 1 by x it is, or we can take tan inverse x also, in whichever form we want to take. So tan inverse of 1 by x is equal to, here there is equal to cot inverse x if x is positive. And if x is negative, then it is minus pi plus cot inverse x. So why there is a variation here? In earlier two cases, sin inverse 1 by x is cosec inverse x. Sec inverse 1 by x was cos inverse x. But in tan inverse 1 by x, it has two different cases. So here the principal value takes place into account. So in NCRT, it is only this one which is given. And it is mentioned when x is positive. But it has skipped where what if x is negative. So when you study other than NCRT, there you come to know that when x is less than 0, then this comes. So why it happens? So if we derive it, it will be clear to us. So tan inverse of 1 by x is equal to theta we have taken. Let Since x belong to real number here, except 0, because in the denominator we can't take 0. So tan inverse, it can take any real value, because we know that tan inverse can take any real value. It is not between -1 and 1 only. And theta belongs to minus pi by 2 to pi by 2. That is the principal value of tan. So theta belongs to minus pi by 2 to pi by 2. Then we take tan. So tan of tan inverse 1 by x, it becomes equal to tan theta. Now tan and tan inverse cancels, and it becomes 1 by x is equal to tan theta. Now when we write the reciprocal, so x is equal to 1 by tan theta. So x is equal to cot theta. Now if we see x is equal to cot theta, we apply cot inverse both the sides. So this would be like this. So first write till here, then we'll proceed. Here then there will be a major situation which will come. Till here it is fine. Everything as according to the process. If you have written till here, then we will proceed. And if any doubt in any step, you can ask. Written till here. I hope so. So
Sir.
I'm proceeding. Okay. So if you see that cot inverse cot theta is there. So can cot inverse and cot can cancel here and it become cot inverse x is equal to theta? Yes, if this theta is in the principal value range of cot. But what is theta? Theta is between minus pi by 2 to pi by 2. Is it the principal value range of cot? No. Principal value range of cot is 0 to pi. So it cannot be between minus pi by 2 to pi by 2. So now then there is a clash. In earlier cases, sine and cosec both have the same principal value. Cos and sec both have the same principal value. But here in tan and cot, both does not have the same principal value. So now we say that if it is, if the value which we have taken above, which was 1 by x, so there will be two cases now. So here, two cases will come. Case number one, that if x is positive. And case number two, if x is negative. If x is positive, if this 1 by x will also be positive. So tan inverse of 1 by x, which will give an angle theta, theta will be between 0 to pi by 2. And in case 2, when x is negative, then 1 by x is also negative. Then tan inverse 1 by x theta will be between minus pi by 2 to 0. So that is minus pi by 2 to pi by 2 has two different cases. One is 0 to pi by 2, another is minus pi by 2 to 0. In case of 0 to pi by 2, cot inverse also have 0 to pi by 2 principal value range. So then we will say that cot inverse x, which is equal to cot inverse cot theta there, which we have just written above here, can be written as theta. Because 0 to pi by 2 is a part of cot also, principal value range. So we'll say cot inverse x is equal to theta. So we will say that this theta, which we initially took as tan inverse 1 by x, first equation. And here we are getting theta as cot inverse x. This is the second equation. So we'll equate 1 equal to 2 and say that tan inverse of 1 by x is equal to cot inverse of x. So this is true if x is positive. So this is the
So
first.
here, 0 to pi is the principal value of tan.
No, cot.
Cot, okay.
So tan inverse 1 by x is cot inverse x when x is positive. That is fine. Now what happens when x is negative? So when x is negative, then theta is between minus pi by 2 to 0. Yeah.
Here 0 to pi is in both cases, like cot and tan both it will come 0 to pi.
No, in
will be
tan it
part.
is minus pi by 2 to pi by 2. In cot it is 0 to pi.
Okay.
That is why there is a clash. No? 0 to pi by 2 is in both. But when x is negative, then cot will be between pi by 2 to pi and
Will be
tan will be minus pi by 2 to 0. So here what we will do now, that we will write cot inverse of x is equal to cot inverse of cot theta. Now we can't cancel cot inverse and cot because theta is in minus pi by 2 to 0, which is not the principal value of cot, remember. So you will do some manipulation as we were doing in the yesterday's class. So we will write it as cot of pi plus theta. Because cot of pi plus theta is same as cot theta by the trigonometry of class 11th, which we have studied earlier, allied angle rule. Cos 180 degree plus theta is cos theta. And when theta belongs to minus pi by 2 to 0, then pi plus theta will belong to pi by 2 to pi. You will add pi to both. So pi minus pi by 2 is pi by 2 and pi plus 0 is pi. So cot inverse of x is equal to, now this is the principal value of cot. It is pi by 2 to pi, which is the principal value of cot. Because 0 to pi is the principal value of cot. It is a part of it. Now cot inverse and cot will cancel and it will become pi plus theta. So you will say now cot inverse x is equal to pi plus, and what was theta? Tan inverse 1 by x. So it is tan inverse of 1 by x. So you will say that tan inverse of 1 by x is equal to minus pi plus cot inverse of x. So this is the relation between tan inverse 1 by x and cot inverse x if x is negative in the second case. So that is why here when x is negative, tan inverse 1 by x is minus pi plus cot inverse x. So write these two cases. I will scroll down when you will return till here. So it is all the game of principal value. Everywhere you will see that principal value will play some role. Should I scroll it down?
Yes, sir.
Okay. So you may come across questions like this also, like if I give you to try, then we will discuss. One question I'm giving you right now. Sine of tan inverse 1 by 3. So what will be the value of this? So now there's sine outside, here it is tan inverse. So how would you approach such questions? Just give it a try, then we'll see. I'm coming in a minute. Just try this. Yeah. Any progress?
Sir,
Yes.
is it 1 by 2?
Sorry.
Is it 1 by 2?
1 by 2. Okay, Shahbaz is saying it is 1 by 2. but I don't think it would be 1 by 2. How have you done it? So what we do, let us check. What we do, we consider this is the value, okay, and this will give you an angle. Tan inverse 1 by 3 will be an angle, and then sine will act on it, and again you will get a value. So this is an angle. So you can suppose let tan inverse of 1 by 3 is the angle theta. So tan theta is equal to 1 by 3. Now what we have to find is sine of tan inverse 1 by 3. And what we have let that tan inverse 1 by 3 is theta. We have to find sine theta. So it is sort of that tan theta is 1 by 3, and you have to find tan theta is 1 by 3, and you have to find sine theta. So you will make a right angle triangle. Tan theta is perpendicular by base, so 1 by 3. And this will give you the hypotenuse root over 10, root over p square plus b square. And sine theta will be, because this is theta, 1 by root 10. So you will say that this value is 1 by root 10. So this is how we will approach this type of question. This would be the answer. So next question is for you, similar to this, the approach would be similar. You have to find cos of tan inverse 2 root 2. Mohammad Sharif asking, how did we get 1 by root 10? Because sine theta is perpendicular upon hypotenuse. Tan theta is perpendicular by base. So if tan theta is given 1 by 3, so we can say that perpendicular is 1 and base is 3, and this is the angle theta. Now we know that hypotenuse is equal to root over p square plus b square. So we get it as root 10. Now sine theta is perpendicular by hypotenuse, so it will be 1 by root over 10. Because this will be the hypotenuse, this will be the perpendicular, this will be the base. Are you trying this one? Cos of tan inverse 2 root 2?
So
So here also what you will do? Tan inverse 2 root 2 is equal to theta. So tan theta will be 2 root 2, which means this is perpendicular by base, 2 root 2 by 1.
is it
What
1
will
by
be
3?
Yeah, 1 by 3, correct. So hypotenuse will be 3 because hypotenuse square is base square plus perpendicular square. So it will be 9. 2 root 2 square is 8, right? So when you will see cos of tan inverse 2 root 2, you will say it is cos of theta. Cos theta is base upon hypotenuse. So this will be your answer. Okay, so one more question of this type you are doing, but it is a little different type. It says solve cos of tan inverse x. So here x, we don't know what x is. We have to find the value of x is equal to sine cot inverse 3 by 4. So you have to find x actually. Okay, Mohammed Sharif is asking, sir, can we just reverse cot because cot is inverse of tan? Mm, yeah, you can do this now. Like cot is not inverse of tan. Cot is reciprocal of tan. So if it is cot inverse 3 by 4, you can write tan inverse 4 by 3. This is what you can do. This we have studied above. But this won't help actually. This will not help you. So what you have to do here is you will take this right hand side as we were doing in above case. Sine of cot inverse 3 by 4 and let, this is first part of it, let cot inverse 3 by 4 is equal to theta. So cot theta is equal to 3 by 4. So in this right angle triangle, cot is base by perpendicular. So 3 by 4. And hypotenuse will become 5 because hypotenuse will be root over 3 square plus 4 square. So when you will find sine of cot inverse 3 by 4, you will say it is sine of theta, which is perpendicular by hypotenuse, so 4 by 5. So what we get here is that this value is 4 by 5. This right hand side is 4 by 5. So therefore, our equation becomes cos of tan inverse of x is equal to 4 by 5. Now, similar thing you have to do for LHS also. So first write till here. So similar thing you have to do in the left hand side, like you will take this cos of this tan inverse of x as another angle alpha, suppose. Theta we have used, so I'm taking alpha. So tan alpha will be x. In earlier cases, the value was given, here the value is x. So take x only and take it as perpendicular by base, as tan is perpendicular by base. And this is angle alpha, this is x, this is 1. So hypotenuse will be root over 1 plus x square. So you can say that cos of tan inverse x, which is the left hand side, is cos of alpha, which is base upon hypotenuse, 1 by root over 1 plus x square. Now, after doing this, you can just equate a 1 by root over 1 plus x square here. To 4 by 5, the right hand side. So whatever we have done on the right hand side, the same thing we have done on the left hand side. So this means root over 1 plus x square will be 5 by 4. From here, can you get the value of x? Squaring both the sides and then taking 1 on the right hand side. So when you will square, you will get 1 plus x square is equal to 25 by 16. So x square will be 25 by 16 minus 1. We will take LCM, it will become 9 by 16. So x will come out to be root
Less
over
or minus 3.
plus minus 3 by 4. So this will be the answer.
Sir, I was having a doubt.
Sorry,
Sorry, here I was having a doubt.
I didn't get you what you are saying.
Sir, here we took the angle alpha. Why we are not taking it as theta?
Can you speak
Like
little
this,
slowly?
same angle. Why we can't take like
Because
theta? Why we are